Deep inside a flooded cave on Mexico's Yucatan Peninsula, technical divers descended nearly 140 feet into total darkness, following a passage that had been sealed underwater for thousands of years. What their lights found resting on a ledge was a skeleton, nearly complete, belonging to a teenage girl who had fallen into the cave system during the last ice age and never climbed out. Researchers named her Naya. When scientists finally extracted usable DNA from her remains, radiocarbon dating placed her at somewhere between 12 and 13,000 years old. One of the oldest and most complete genetic samples ever recovered from the first Americans. Her genome definitively linked her to modern Native American populations, closing one question and opening dozens more. Because Naya was never alone. She was one thread in a genetic story stretching back more than 20,000 years, involving multiple waves of migration, an extinct human species whose bones have never been found. Ocean crossings historians once dismissed as fantasy, and DNA that shouldn't exist according to everything we thought we knew. The question was never simple. Who discovered America? The answer, written in DNA, is stranger than anyone expected. To understand how Naya's ancestors reached that cave, you have to go back further than any single skeleton, back to a genetic split that happened long before anyone set foot in the Americas. Around 23,000 years ago, deep in Ice Age Siberia, a population of early Asians broke away from their neighbors. This was not a migration yet. It was a divergence, a genetic branching point that geneticists can now read directly out of ancient bone. But here is the detail that upends the simple version of the story most people grew up with. These early ancestors did not walk straight into the Americas the moment they split off. Instead, they spent thousands of years living somewhere that no longer exists on any modern map. That place was Beringia, a vast stretch of grassland connecting Siberia to Alaska, submerged today beneath the cold water of the Bering Sea. At its peak, Beringia was larger than Texas and Alaska combined, an entire landmass now erased by rising water. For thousands of years, this population lived, hunted, and adapted here, isolated from both Asia behind them and the Americas ahead. It was, in effect, a holding chamber for the future population of two continents, a place where genetic drift and isolation reshaped a people before they ever crossed into a new world. Nobody planned this pause. Geography simply built the pause for them, and it lasted long enough to leave a permanent signature in the DNA of everyone who eventually walked south into the Americas. The proof of that pause did not come from theory. It came from two small skeletons buried in Alaska. In 2013, archaeologists working at the Upward Sun River site uncovered the remains of two infants, laid to rest together roughly 11,500 years ago. When researchers extracted DNA from those tiny bones, what they found did not match any known Native American population, past or present. It was something new entirely, a previously unidentified group scientists came to call the ancient Beringians. Their genetic signature was distinct enough to stand as its own branch on the human family tree, neither fully the ancestors of northern Native Americans, nor of the southern lineages that would eventually populate two continents. This single discovery proved something remarkable. Beringia was not a simple corridor that people passed through quickly on their way somewhere else. It was home to multiple distinct populations, living side by side or in succession, each carrying slightly different genetic inheritances before the Americas had even been reached. The infants themselves, buried with care, food offerings, and stone tools placed beside them, represented a population that would eventually vanish as a distinct group, absorbed or replaced by later arrivals, leaving behind only this frozen genetic snapshot. Without their bones, without the technology to read DNA locked inside them for 11 millennia, the ancient Beringians would have remained invisible forever. A population erased from history except for the molecules preserved in two small skeletons in the Alaskan permafrost. But the ancient Beringians were not the first chapter of this story either. To find the deeper roots, researchers had to travel far from Alaska, into the heart of northern Siberia, to a site called Yana Rhinoceros Horn. Dated to roughly 32,000 years ago, Yana is one of the oldest and most remote human settlements ever discovered in the Arctic, predating the Beringian population by tens of thousands of years. The people who lived here left behind stone tools and the remains of woolly rhinoceros and mammoth, evidence of a population that had already mastered survival in brutally cold, resource-scarce conditions long before any land bridge migration began. Their genetic contribution became known as ancient North Siberian ancestry, and it did not disappear when these populations moved or mixed with others. Instead, it became one of the deep genetic ingredients that fed into the ancestors of the first Americans, blending with East Asian lineages to help form the genetic profile that would eventually cross into Beringia and beyond. This detail matters because it shatters the idea of a single clean point of origin. There was no one moment, no one population, no one place where the story of Native American ancestry begins. Instead, there's a layered convergence. Ancient North Siberians merging with East Asian populations. That combination pausing in Beringia, and only then moving forward into a new continent. Each layer left a measurable trace, and each trace is still detectable today. Sitting quietly inside the genomes of living people who have no idea their DNA reaches back to a rhinoceros hunting camp in the Siberian Arctic 32,000 years ago. For decades, the accepted timeline held that humans did not reach the interior of the Americas until around 13,000 years ago, tied to the appearance of distinctive Clovis stone tools. Then, White Sands National Park in New Mexico rewrote that timeline entirely, not with bones or artifacts, but with footprints preserved in ancient lake sediment. In 2021, researchers published findings dating these prints to between 21 and 23,000 years old, pushing the confirmed presence of humans in the Americas back by at least 6,000 years. The footprints themselves tell a startling story. Adults, teenagers, and children walked across the same muddy ground where giant ground sloths and mammoths once roamed. Some tracks show the unmistakable pattern of humans stalking these massive animals, following at a careful distance. Others reveal people carrying heavy loads, their gait altered by the weight pressing down with each step. There are no stone tools here, no burials, no DNA. Just footprints, frozen in time by sediment that hardened around them and preserved a single afternoon, or perhaps a single desperate hunt, for over 20,000 years. What makes White Sands so disruptive is not just the age of the prints, but what that age implies. If people were already walking across New Mexico more than 20,000 years ago, then the story of migration was already well underway during the last glacial maximum, not after it, forcing researchers to reconsider everything they thought they understood about when and how quickly the Americas were truly reached. Footprints alone could not confirm sustained human presence, so researchers turned to sites where people had clearly stayed, built, and lived. In southern Chile, archaeologist Tom Dillahay spent years excavating Monte Verde, a site that produced stone tools, wooden implements, and even preserved fragments of meat dating back 14,500 years. Most remarkable were the medicinal plants found at the site, sourced from locations hundreds of miles away, proof that these early Americans had already built extensive trade networks and a sophisticated understanding of plant medicine long before written history began. Far to the north in Oregon, the Paisley Caves yielded something stranger than tools or bones. Ancient human DNA extracted directly from fossilized feces, dated to 14,300 years old. This coprolite evidence confirmed that people were living in the Pacific Northwest earlier than most researchers had previously believed possible. And in central Texas, the Gault site produced an entire toolkit of sophisticated craftsmanship, projectile points, scrapers, and blades dating between 16 and 20,000 years old, alongside traces of red ochre pigment suggesting these early Americans engaged in symbolic behavior, possibly body painting, thousands of years before anyone assumed complex culture had taken root on the continent. Taken together, these three sites, separated by thousands of miles and vastly different environments, prove something the footprints alone could not. Humans were not simply passing through the Americas in a single rapid wave. They were settling, adapting, trading, and developing culture across two continents simultaneously, far earlier and far more broadly than the traditional migration story ever allowed for. The genetic story of the first Americans takes its strangest turn with a species most people have never even heard of. Denisovans were an ancient human lineage that lived across Asia tens of thousands of years ago, identified only in 2010 when scientists analyzed DNA from a single tiny finger bone discovered in Denisova Cave, deep in Siberia's Altai Mountains. That cave shows evidence of occupation spanning more than 200,000 years. And remarkably, in 2018, researchers found a bone fragment belonging to a girl whose mother was Neanderthal and whose father was Denisovan, direct proof that different human species interbred far more than anyone once assumed.
What makes this relevant to the Americas is that traces of Denisovan ancestry did not stay confined to Asia.
Certain Native American populations, particularly in South America, still carry small fragments of Denisovan DNA today. The Caridiana people of Brazil carry roughly 0.2% Denisovan ancestry, and the Surui show a similar genetic signature, inherited from interbreeding that occurred in Asia long before any migration toward the Americas began. Scientists believe these ancient genes may have done more than simply persist.
They may have helped early Americans survive brutal Ice Age conditions, contributing to stronger immune responses, better cold tolerance, and more efficient oxygen processing at high altitude. Adaptations still visible in some populations living in mountainous regions of the Americas today.
A species that vanished from the fossil record entirely left no bones behind in most of the world. Only a quiet genetic signature, still detectable in the blood of people alive right now. Before I show you the last part, if you want to look at your own results and see where Denisovan and ancient migration ancestry fits into your bloodline, I put a full 3-volume PDF bundle over at the OriginDNA website. It shows you how to read your raw data and find matches beyond what Ancestry or 23andMe tell you. Link is in the description. But stay right here, because what comes next is the part most people completely miss. For decades, the dominant theory held that the first Americans crossed exclusively through an interior corridor, walking south once the ice sheets parted. But mounting evidence points to a second route entirely, one that ran along the coastline rather than through it. On Haida Gwaii, an island system off British Columbia, researchers uncovered evidence of continuous human occupation stretching back 14,000 years, complete with shell middens, stone tools, and clear signs of sophisticated marine resource exploitation. Farther south, California's Channel Islands produced even earlier evidence. At Arlington Springs on Santa Rosa Island, human remains dated to 13,000 years old proved that people had already developed the seafaring capability needed to reach an island separated from the mainland by open water. Nearby, the Daisy Cave site on San Miguel Island revealed 11,000 years of continuous occupation, along with fish hooks, shell beads, and the remains of dolphins, seals, and sea otters. Clear evidence of advanced marine hunting technology. This gave rise to what researchers now call the kelp highway theory. The idea that small groups traveled by boat along a nearly continuous underwater forest of kelp stretching from Alaska to South America, rich with fish, shellfish, and marine mammals at every stop along the way. Supporting this theory, the Quebrada Jaguay site in Peru revealed a maritime-adapted community living on the South American coast 13,000 years ago, complete with fishing nets, hooks, and the remains of anchovies and sardines. The interior migration was never the only path. An entire second population may have moved south by sea, following the coastline in small boats, long before anyone crossed the continent on foot. Once inside the Americas, this founding population did not remain a single unified group for long. Genetic evidence shows a major split occurred around 15,000 years ago, dividing early Americans into two distinct lineages, one that would populate the north and another that would spread through Central and South America. The clearest evidence of this branching comes from Montana, where the Anzic, one burial, dated to 12,600 years ago, revealed a young boy buried alongside distinctive Clovis stone tools and red ochre pigment. His DNA placed him firmly within the ancestral population responsible for giving rise to every Native American group living south of the former ice sheets. Further evidence came from Nevada, where the Spirit Cave mummy, dated to 10,600 years old, showed genetic ties specifically to modern populations in Central and South America, confirming that this southern lineage had already begun diverging and spreading independently. Perhaps the most publicly contested case came from Washington State, where the discovery of Kennewick Man, dated to 9,000 years old, initially sparked controversy when some observers claimed his skull looked distinctly European. Detailed genetic analysis published in 2015 settled the debate decisively, showing that Kennewick Man was in fact most closely related to modern Native American populations, particularly the Colville tribes of the Pacific Northwest. Each of these individuals, separated by thousands of years and thousands of miles, tells the same underlying story. A single founding population entered the Americas and then split,
diversified, and evolved independently across 2 continents, leaving behind genetic markers that modern science can now trace with startling precision. Not every theory about early American migration has held up under genetic scrutiny, and one of the most controversial involves Europe rather than Asia. The Solutrean hypothesis proposed that Ice Age Europeans, from what is now France and Spain, crossed the frozen North Atlantic and reached North America directly, long before any Beringian migration occurred. The theory rested on similarities between Solutrean stone tools, dated between 22 and 17,000 years old, and found at sites like Laugerie-Haute in France, and Clovis points discovered across North America. Supporters pointed to sites such as Cactus Hill in Virginia, where stone tools were claimed to predate Clovis technology, and the Meadowcroft rock shelter in Pennsylvania, which produced controversially early dates used to bolster the European origin argument. Most geneticists today reject the Solutrean hypothesis outright, citing overwhelming DNA evidence that traces Native American ancestry back to Siberia, not Europe. Yet one genetic detail keeps the debate from fully disappearing. A mitochondrial marker called haplogroup X2A appears in roughly 3% of Native Americans, with notably higher frequencies among certain northeastern tribes, including the Ojibwe of the Great Lakes region and some Sioux populations. This same marker has even been found in ancient remains at Florida's Windover site, dated to 7,000 to 8,000 years old. For a time, this seemed to hint at forgotten contact between Europe and the Americas, long before the Vikings ever set sail. Most scientists now believe X2A actually represents an ancient Asian lineage carried over during the original migration rather than any transatlantic crossing. But the marker remains a genuinely unresolved thread in an otherwise well-supported genetic story. While the Solutrean theory remains unproven, at least one instance of pre-Columbian contact between the Old World and the Americas is settled beyond doubt. By the 11th century, Norse explorers had reached the coast of Newfoundland and established a settlement known as L'Anse aux Meadows. Archaeological excavations, first conducted after the site's 1960 discovery, revealed 8 buildings constructed in traditional Norse style, along with a bronze pin, iron boat nails, and slag from iron smelting. Artifacts confirming a genuine, sustained Viking presence rather than a brief landing. Carbon dating placed the occupation between 990 and 1050 AD. Related Norse evidence has since surfaced at Point Rossi and Tanfield Valley further north, hinting that Viking exploration extended even beyond this single settlement. Genetic evidence shows this contact went both directions. Some modern Icelanders carry a mitochondrial marker called haplogroup C1e, typically found only in Native American populations, dating to approximately 1000 AD. Precisely when Vikings were active across the North Atlantic. Researchers believe this DNA traces back to a Native American woman brought to Iceland from Vinland or Greenland, a detail echoed directly in the Icelandic sagas, which describe captives taken during Norse voyages. But the Vikings were not the only ancient seafarers to make contact with the Americas. Around 1200 AD, Polynesian voyagers reached South America, a connection confirmed through genetic analysis of Easter Island populations, showing clear ties to indigenous Colombian groups. Supporting this, the South American sweet potato was already being cultivated across Polynesia by 1000 AD, centuries before European contact, proof of a working maritime network stretching across the widest ocean on Earth. Which brings the story back to Naia, resting for 13,000 years in the dark water of a Yucatan cave. Her DNA, the thread that ties every wave in this story together. Siberian ancestors, Beringian isolation, coastal voyagers, Viking captives, Polynesian sailors, but even her genome does not close the case entirely. Buried inside the DNA of the Curitiana, the Surui, and the Zavante peoples of Brazil sits something science still cannot fully explain. Fragments of genetic material from an unknown human lineage that split off the human family tree more than 300,000 years ago, long before modern humans are believed to have even existed. This phantom ancestry matches no known fossil, no identified species, no site ever excavated. And different Native American groups carry different versions of it, suggesting more than one unknown human population may have reached the Americas across separate waves, tens or even hundreds of thousands of years apart. Until researchers can trace these phantom sequences back to a source, the question first asked at the very beginning remains genuinely open. Who discovered America?
The honest answer is that dozens of populations did, again and again, over more than 20,000 years, each one leaving behind a signature that still lives on in the blood of people walking the streets of Lima, Bogotá, and Sao Paulo today. Naya was never the beginning of this story. She was simply the moment we finally learned how to read it.
Thanks for watching this video, but before you go, don't let your DNA results just sit there unanswered. Tap the link on the description to download your ebook and find out what your raw data is hiding.